Okay, question 7, we've got questions on light and reflection and refraction. It's quite a tricky question, the whole of 7. So white light includes all the colours of the visible spectrum, and the crucial part is knowing that the primary colours are RGB, red, green and blue. The book appears green, so I'm now just going to here's my book, and I know that it's green. All right, so there's my book, but I'm going to put G because it's green. And what does that mean? I know it reflects green and it absorbs blue and red. So I'll put dot B dot R. There we go. So there's my crucial part. So the green object reflects green, absorbs blue and absorbs red. And we've got a white beam going through there, red, green and blue. So I'm just going to get rid of that. There we go. It says a red filter is placed between the source. So here's my filter with a dashed line and it's red. So the red filter's going to transmit red and it's going to absorb red and absorb green. So now we're just going to look, well, what happens to this red light? Well, this red light is absorbed. There's no other light there. So if this red is absorbed, dot, then there's no light. And therefore it'll appear black. Okay, so that's that question done. There's a clear image of the building can be seen on the surface of the ball, so we can see that this is reflecting, and this is going to be specular reflection, and that just means that there is if there's the normal line, it means that the angle of incidence theta I equals the angle of reflection. And then we're looking for why can we see it? Well, it's going to be specular reflection. There is a pattern which enables us to see a decent reflection. So that's going to be not A, not B, that's going to be C. Specular reflection. On to the next one. Explain why the surface of the ball gives a clear image. You may draw a diagram. So I've given you this one here. And we've got if the light was shining in that way, theta I equals theta R. The angle of incidence equals the angle of reflection. We're just going to put that into words. So the surface is smooth and shiny like a mirror, and I've drawn a mirror surface there. The light is reflected and the angle of incidence equals the angle of reflection. That's my model answer for it. Next one, we've got rays passing through different lenses. So A, that shape is a convex lens, and we can see it brings rays to a focal point. This one is a concave lens, and we can see we use the focal point in front. This is spreading out the rays. So convex lenses converge, concave lenses diverge. So give us a similarity. Well, they're both refracting light. They're both bending light. So both refract light. Difference, figure 9a is the convex lens. It's going to converge the light. Figure 9b is going to diverge the light because it's a concave lens. So it's just testing us on the names of the lenses and what's happening, how they're the same, how they're different. State how the power of P is different from Q. So we can see Q is more curved. Because it's more curved, it's going to refract more. So the power of P must be less than Q. So P is less powerful as it is less curved. Mark. And then we've got a 6 marker where it's going to ask us about those. And it says you may add to figure 11a and 11b to help. That's not you may, that is you will add. So what am I going to do? Well, I'm going to say, here's my incoming light, my incident light. So I'm going to label angle theta I. We always measure the angles from the normal. Here is my refracted ray, theta R. If I wanted to then look at it, I told you get your pencil case out, side A, side B. Side B is going to hit first. It's going into air that's less dense. So this side's going to go faster, B, and therefore it's going to bend away from the normal. Okay, so I've tried to teach MTLA. If it's more dense towards, less dense away, and we can see this has gone away from the normal. Okay. So that's the basics there. And here, so refraction takes place on this boundary, on this surface. Done. And we've labelled the diagram. And we can see that theta R, the angle R, is greater than theta I. There we go. Well, on this one now, there's theta I, there's theta R, and we know they equal each other because this is specular reflection. And this is total internal reflection. But we need to know that the angle that this takes place is 42 degrees. Really important. And it's caught you out loads of times in all sorts of different papers because it's some learning from year 9. So now let's put that into words. So let's do 11A first, which is refraction. The angle of incidence and the angle of refraction are marked. Yep, done that. Theta I and theta R are marked. Light is refracted at the boundary of the different density materials. Light speeds up as it moves into less dense air. Yep, we've said that, and we've even used the model with the sides of the car. The refracted ray bends away from the normal. So theta R is greater than theta I, or theta I is less than theta R. Same thing. All done. So we've talked about it, we've talked about the angles. Now let's go to total internal reflection. So the critical angle for glass is 42 degrees. So total internal reflection takes place inside a denser object. All right, so inside this glass. The light stays inside the glass. The angle of incidence equals the angle of reflection. Total internal reflection can only occur when the incident light is in a more dense medium. So if I'm in glass, move into air, yep, that can take place. If I was in air, move into glass, couldn't take place. And that's all the basic knowledge for that 6 marker. So a lot to get right there. I think this is one of the trickier questions. And there we go.